DGX Spark will be ready, will be available shortly, probably in a few weeks.
DGX Spark is coming. It's always been coming. But while we wait, GMKTec is not sitting around. They just dropped the Evo X2, a mini PC with 128 gigabytes of RAM that's shared with the GPU, ready for local LLMs and machine learning, and it costs less than half the price of the DGX Spark. Hey, maybe the Spark is out by the time this video is edited, and in that case, I'll leave my words. I've ordered it also just to make sure I test everything here, so make sure you don't miss that. And why would anybody still care about the DGX Spark? I'll get into that in a bit too. Now, this Evo is here and it's real, sort of. They are a little bit hard to get because it's got that new AMD chip in it, but they're trying to ramp up production because it's so popular. It's a beast compared to most of GMKTec's lineup, and it's loaded with ports. 2 USB 4 ports, 5 USB-A ports, SD card reader, HDMI display port, 2 headset ports, and of course a 5 gigabit Ethernet. 5 gigabits. We're up to that now? Nice. But the real headline is what's inside. That's AMD's new Ryzen AI Max Plus 395. Yes, I got it right. 16 cores, 32 threads, and up to 5.1 gigahertz. And the internal GPU that's supposed to rival a 4060, yeah, the RTX 4060, is the Radeon 8060S, and they come in 64 gigabyte. This is the 128 gigabyte version, which I'll be testing right now for LLMs. That's LPDDR5X, which is a pretty fast mobile memory, 8000 megahertz. It also has dual PCIe Gen 4 SSD slots inside. So yeah, upgradable too, up to 16 terabytes, and it's got Wi-Fi 7, which, you know, you might have that. Some people have it. I don't have it. Of course, this PC can handle the latest games without breaking a sweat. Huh? I said it can handle the latest games without breaking a sweat. But what really sets it apart is this APU. That's that combination of the CPU and GPU on the same chip with the unified memory setup. Well, it's not exactly unified memory. The memory can be shared, but it's different from Apple Silicon's UMA, or Unified Memory Architecture. It's called static partitioning. Thanks for that, Casey. What does that mean for us? This thing is built for running local LLMs, just like I demoed in my members live stream when I first got it in. You might have also recently seen my video where I test that same chip with 128 gigs on this device. This is Asus's Flow Z13, but the thermals on these machines are very, very different. So I wonder if this thing is going to be pushing that chip to its limit, because the fans on this thing are everywhere. By the way, Mac Minis, we're going to compare it to that as well. Why? Because bang for the buck, they do really well. Now, before we get going, let's kick off one test just to get a baseline of what this feels like. I do have a bunch of models here, and I'll go through the results in a bit. And a very popular model is this Qwen 3 32 billion. This is the Q4, so the quantization is 4. And LM Studio is telling me I can offload 64 out of 64 layers, so let's do that. Load model. Let's make sure that this thing is in fact getting loaded on the GPU. So let's check out Task Manager. It does get loaded into memory first, system memory. We're split up 64 and 64. 64 for system, 64 for GPU. So it gets copied to the system memory first and then copied over to the GPU memory. And that's what this static partitioning of memory is all about. It's not unified memory like it is on Apple. We'll see some differences in a bit. Model's loaded. You can see it in dedicated GPU memory right here. And we'll say hi. I know. Y'all hate it when I say hi, but it's one token and it gives the best possible results. I've given the model thousands of tokens before as input, and the results are just slightly different. So it's not a huge deal as far as the context size, but here we'll get the fastest possible speed so we can compare something, right? Because lots of people have different kinds of prompts that they use. How do you compare? Use the same prompt. 10.58 tokens per second here, which is pretty reasonable for a 32 billion parameter model that's 18.4 gigabytes in size. Let's do one more. A model that might not necessarily fit into a RTX 4090 or even an RTX 5090, which is this one right here. Llama 3.370 billion Q4. It's 39 gigabytes on disk, and LM Studio is telling me I should offload only 75 out of 80 layers to the GPU. I'm gonna push it all the way to 80 and see what happens here. By the way, if you're kind of new to this, if you offload even any layers to the CPU, things are just gonna go downhill really fast and become very, very slow. You want everything to be on the GPU. Well, it's not complaining yet. Look at that spike in dedicated GPU memory. We're up to 43 gigabytes used on that one, and it looks like it loaded. So I'm gonna start a new chat and let's do a little hi there. It's going. It's not as fast, but it's going. 5.1 tokens per second here. And you can see that nice spike on the GPU, which means it's fully utilizing the GPU. That's good. The CPU had spikes, but this is not the processing. The processing is happening on the GPU, so that's good. And we're about 170 watts or there, about 172, 174. That's the maximum that it's working at. It is again set to best performance. We'll switch over to the Max for a moment to take a look at the most important factor in figuring out the speed of these LLMs, memory bandwidth. And check out this site. What is this, from the 90s? I think it is, actually. Look at that, it's got borders. Remember table borders? Anybody was around back then? Anyway, this is called the Stream Benchmark, and this has been around in the industry for a long time, measuring memory bandwidth. Even on the AMD site, they point to this benchmark. So this is good to run on all systems because I compile it on that system. So I compiled this and I ran this on the Mac. This right here is the M4 Mac Mini. And according to Apple, the M4 chip has the memory bandwidth of 120 gigabytes per second. Pretty good already, and that's just the base model. So right now, I measured this running Stream, and if we look at this triad number, we're getting 96 gigabytes per second or thereabout. It's not 120 like Apple advertises, but it's pretty close. So we're going to consider that fact that it's just a little bit less than the advertised number. So here I've got DeepSeek R1 Distill Qwen 7 billion parameter model with a Q4 quantization. It's about 4 gigabytes on disk. Let's load that up, and everything is going to the GPU here. Load it up pretty quickly. And here we go, 21 tokens per second. Let's keep an eye on the GPU history here while I run another prompt, and I'm gonna have it write a little bit of a longer output. And we are at 31 watts, which is actually pretty decent. What am I saying decent? I mean, this is pretty good, right? 31 watts. We got 19.94 tokens per second, and you can see that the GPU was pretty much fully utilized while that was going on. All right, I know what you're gonna say. I didn't do the same model on the GMKTec. Let's do that. But I'm going to tell you right now, it's going to be much faster. Yes, it sure is. And the result is 43 tokens per second here. Why is that? This machine is so much faster than the M4 Mac Mini with this. We can stop there. I mean, now you know. But we're gonna get a little bit more nerdy here. So these days, I'm constantly flipping between models. GPT-4o for notes and email, Claude for code refactors, Flux for image generation, Kling for video, 4 tabs, 4 bills, and counting. Enter Chat LLM Teams. There's one dashboard that houses every top LLM, and Route LLM picks the right one for you for a given task. O4 Mini High for fast answers, Claude Sonnet 3.7 for coding, Gemini 2.5 Pro for big context, and even adds GPT 4.1 before ChatGPT has it. Chat with PDFs and PowerPoints, then generate decks and docs and do deep research all in the same chat. Need human-sounding copy? The Humanize toggle rewrites text to beat AI detectors. Spin up agents and run code with AI Engineer. I built my first bot in just minutes. Track artifacts, create GitHub pull requests, and debug from the same interface. Need visuals? No problem. Use Flux or Ideogram and Recraft for images, Kling, Llama, and Runway for video, all built in. And the kicker is just $10 a month, less than one premium model. Head over to chatllm.abacus.ai or click the link in the description and level up with Chat LLM Teams. Now, a lot of you might already know that there's something called Llama CPP, which is the backbone on what LM Studio runs on. And Llama CPP, when compiled for the platform, you can compile it for ROCm, you can compile it for Vulcan, you can compile it for the CPU only. There's just different optimizations and different libraries you could include when you're compiling Llama CPP. If we take a look at LM Studio and the settings here behind the scenes, you can take a look at runtimes. We've got CPU, Llama CPP, which is available here, but also Vulcan, Llama CPP. And Vulcan is a cross-platform kind of library that basically allows you to use this on Linux, use this on Windows. It'll work on an Intel machine, it'll work on AMD machine, but there's a little bit of an overhead to that, to doing it that way, the cross-platform approach. The more direct approach is something called ROCm for AMD processors. Unfortunately, ROCm is not available, and I'll come back to that. You can see that here. There's more to that story though, and ROCm support is coming soon, but I'll talk about that momentarily. Llama CPP, jumping back to that, they give you a bunch of tools that you can use, including something called Llama Bench. So I'm gonna go to my users folder, .lm Studio models, and I'll pick one here. Let's go with LM Studio Community. This DeepSeek R1 Distill is good, and there's GGUF models in here. So I'm gonna grab that Q4 one and pass it to LM Bench. and boom. And you can see here, it is built with Vulcan. So this is going to utilize Vulcan, which is good. This gives us two results. One is PP512. I know, it's a funny word, silly jokes. This gives us the prompt processing, which is what PP stands for. And this is good, 935 tokens per second. That's nice. And we're getting TG128. TG is token generation, and that's 46 tokens per second. So we're kind of close to what LM Studio gives us. 43 there, 46 Llama bench, just to give you an idea how far off we are. And by the way, this is within the margin of error. I can also use Llama bench on other machines like the Mac Mini, because I compiled Llama CPP there as well. Definitely good to be in the nerdy section right now. I sound way more nerdy because I got a little bit of a cold. Running Llama bench with the same model on the M4 Mac Mini, we get a much lower result. 228 for PP512, and TG128 gets us 21 tokens per second, which kind of aligns with what we've seen in LM Studio on the Mac as well. Now, why is this happening? I thought the M4s were supposed to be amazing, but I do have one more thing to show you, which is this Mac Mini. This is the M4 Pro Mac Mini. And some people think, oh, M4 Pro, right? It's just more cores, right? No. That's not the only difference. Yes, it does have more cores. And the M4 Max, which is not available in a Mac Mini, so I have this, that has more cores too. But the thing that's gonna matter most when it comes to this kind of work, machine learning, is memory bandwidth. And here is our result for that. Same model, we're getting about double. Let's confirm that in LM Studio. And yeah, 44 tokens per second for our high prompt. So what gives? Is it just a matter of getting more cores? Well, the way Apple scales their chips is they have the single M4 core. And if you run Geekbench on these, you'll see that the single core result is pretty much the same across the M4 family. The multi-core score is gonna be different, but it scales pretty much linearly. The extra thing that you're gonna get is more GPU cores and also faster memory bandwidth. For the M4, it's 120 gigabytes per second. For the M4 Pro, it's 273 gigabytes per second. For the M4 Max, it's 540 gigabytes per second, or somewhere around there. The M3 Ultra, 819 gigabytes per second. So given that we know those numbers, the Ryzen AI Max Plus chip has a memory bandwidth, published memory bandwidth, of 256 gigabytes per second. Where does that put us? Well, it's much faster than the M4, but it's about 20 gigabytes slower than the M4 Pro. And where's Nvidia's DGX Spark on that? Well, that's at 279. So slightly higher memory bandwidth than the M4 Pro. We'll see what happens when we actually get that in and test it out. Since I'm doing the M4 Pro right now, let's check out its power usage, by the way. And we're at 47 watts. So quite a bit more than the base M4, but nowhere close to the power used by this machine. Now, since we're talking about memory bandwidth, let's take a look at the measurements I actually got using the Stream benchmark. Over here on the M4, I got 96 gigabytes. Out of the 120 that Apple advertises, it's not exactly close to that, but it's good to know that that's how it's measured. So whatever is going on in the Stream benchmark and the way it's measuring it, we're getting a little bit of a loss there. M4 Pro, not bad, 209 out of the 273 that Apple says. What about this machine? Let's take a look at that. Let's run this one here. And we're getting 120. 120 is way lower than I would expect because we wanted 256, right? And there's a bunch of machines coming out with this chip that are gonna have the same kind of results here. The Framework Desktop is one of them. B-Link has a couple of machines coming out. The Asus, and finally the first desktop is this one. But 120 is way low. What's going on? Well, it's either the benchmark is somehow not running the way it's supposed to on this machine, and I reran this multiple times, of course, but that tells me that if we are getting such high numbers for Llama bench through Vulcan, which is really nice, 935 and 46, which is even better than the M4 Pro. And if the Stream benchmark is correct at 120, that means that this chip may be able to be pushed further. I'm not sure about that yet, but maybe. And if it is able to be pushed further, maybe it can be even faster. But for now, for practical reasons, results is what matters. And we're getting good numbers here from this machine. Gemma 3, 1 billion, we're getting almost 160 tokens per second here. Llama 3.2, 1 billion instruct, 130. Gemma 3, 4 billion, we're getting 66 tokens per second. Here are the DeepSeek distills we've seen, 44. Gemma 3, 12 billion, now we're getting into really more useful models. 23.9, still a really decent score. 14 billion, 23.7. Qwen 2.5 quarter, 32 billion. 32 billion parameter $1,500 models are actually pretty useful. We're getting 10.8, not the best. I'd rather be over 20, but still 10.8 is reasonable. And finally, Llama 3.3 70 billion Q4, 5 tokens per second. It runs and it runs well, but that's getting into a territory where it's a little bit too slow. Now, here's just an interesting tidbit comparing desktop to the laptop version of the same thing. This is a very, thermally limited machine. It does a really good job, but still, it's a laptop tablet. And you can see that here. This is the results for the Nuckbox Evo X2, which is this, versus that Flow Z13 with 128 gigs. And you can see the little green dots are just a little bit higher than the orange dots for each one of these, except for this one, Gemma 312 billion. The laptop beats the desktop for some reason on that one. And by the way, you'll see that I only ran the 64 gigabyte configuration here for the GPU because that's kind of an even split between the two. I can load really large models that way. And I have a slightly different view here that compares a bunch of different machines. The Flow Z13 with 32 gigs. We've got the Nuckbox Evo here. This is Gemma 312 billion parameter model, 23 tokens per second. And here's the M4 Max machine with 49 tokens per second for that same model. So quite a bit faster, but again, that's the memory bandwidth showing up. Getting back to why we have these very different machines coming up. We have this very unique chip. We've got the Apple-based architecture, which is Unified Memory Architecture, UMA, and we've got this Nvidia Spark coming in a bunch of different varieties of machines. There's going to be the Asus machine, the Dell, a bunch of partners are going to have that chip inside of it, the Blackwell chip. That one has 278, slightly higher memory bandwidth than the M4 Pro and the Ryzen AI Max Plus 395. We'll see how that translates, and I'm also not sure how the memory partitioning is going to work in that machine. But here, we do have static partitioning, which is fixed. And of course, that's a way of dividing memory into set blocks before the computer starts up. So you kind of have to know ahead of time. What's nice about that is it's easy to set up, uses few system resources, and keeps each program in its own space, which makes things a little bit more stable. For example, the same chip here, using Armory Crate, I was able to set to auto, and that gave us pretty bad results when it comes to LLMs, probably due to the extra overhead of moving things around in memory when you have to allocate a certain amount of space to different processes. But static partitioning also wastes memory if a program doesn't use all that space in a block. Big programs that don't fit in a block can't run, and only a limited number of programs can run at the same time. It's okay for simple systems, but not great for modern computers that need more flexibility. That said, will this be a good little sidekick machine with AI support and dev? Yes, it will be great. And it's gonna get even better according to AMD. This is going to significantly improve in theory. I tried getting ROCm to working with a special patched Llama version for a while with no success. AMD is working on supporting ROCm on more of their offerings besides a few of the top discrete GPUs. However, during Computex, they did say they would pay more attention to the LLM community. Hey, that's us. And get ROCm support in more chips, including this one, without having to hunt down and monkey patch a bunch of versions with random pieces of software across multiple obscure GitHub repositories. You'll see a lot of people trying it on this chip and with limited success. For example, Michael Larrabell from Phoronix got this working as long as you use ROCm 6.4.1 and install Ubuntu 24.04, not 25, sticking with the Linux 6.11 HWE kernel, and avoid trying to build DKMS modules on newer kernels like 6.14. And even then, Blender with HIP backend was unstable and Llama CPP triggered segmentation faults. So it's still not super stable, but he says hopefully later in the year. We're close. So it'll be fantastic if AMD follows through, and I'll be sure to test that support when it comes out. For now, we have Vulcan, which does a pretty decent job. Now, what about the price? This thing is not your average cheap Nuckbox. These things are getting serious. Mini PCs are starting to get real value, real chips, because our chips are shrinking and still giving us a lot of power. While it is a mini PC, it's kind of in between a mini PC and a desktop. It's bigger, and the price is a little bit bigger too. $14.99 for the 64 gigabyte version and $2,000 for the 128 gigabyte version that I have here. There is a crazy amount of demand for this particular chip right now. If you ask me if this is an expensive price to pay for this machine, I would say no, because this machine is a beast and a powerhouse in a tiny package. Now, if you compare it to the M4 Mac Mini, you saw that the performance of the Mac Mini is good, but because of the memory bandwidth limitations, it's not going to be as powerful as this thing. Also, the number of cores is much less, so it's going to be less powerful. Also, 64 and 128 gigs of RAM, you don't get that with the M4 Mac Mini. You can get 64 with the M4 Pro, that's this one right here, but then And this machine cost $23.99, so quite a bit more. All right, that's it, folks, for this one. Hope you enjoyed this video. If you did, give it a thumbs up. Consider joining the channel as a member. I did actually run a few tests for members in a live stream when I first got this machine in, so you can sign up down below as well for that. Otherwise, you might be interested in this video right over here. Thanks for watching, and I'll see you next time.